Factorize these then. Let's have a look. Well, here we use this jigsaw puzzle to solve them. So we factorize. So asking us to factorize means that they will factorize. So first line, first term, let's draw our brackets then. 2 for the first, 2 for the second. 1, 2, 3, 4. First line, first term is x squared, so that'll be an x times an x. That's done. Next key in the jigsaw, piece in the jigsaw, last line, last term. This times this must give 2. So that would be a 1 and a 2, a 2 and a 1, a minus 2 minus 1, or a minus 1 minus 2. So those are the 4 possibilities, aren't they, of two numbers that give a product of plus 2. That's the second piece in the jigsaw. Now the last piece in the jigsaw, middle lines, this times x and this times x, lines 2 and lines 3, must give a sum of plus 3. So we can cross out the negatives. This many x's and this many x's must give 3. Oh, that should have been written around the other way, shouldn't it? That should be a 1 and 2. Because this is an x and an x, there's symmetry, so it doesn't matter which one we choose. Both of them will give 3, won't they? So let's put them in then. Plus 1 and plus 2. Plus 1 plus 2. There we go. So that's that one done. And then we can double check at the end. X squared plus 2x plus 1x is 3x's, plus 2 1s are 2. Next one. 4 lines, 2 for the first, 2 for the second. Lines 1, 2, 3 and 4. Okay, first line, first term. Something times something gives x squared. Well, that would be an x times an x. Last line, last term is a 12. So let's write down those possibilities. 12 ones, 1 12s. Because there's symmetry, you don't really have to write them around the other way. Because we can see there's symmetry, so I'm not going to write them around the other way now. 6 2s, 2 6s, 3 4s, 4 3s, and then minus 12, minus 1, minus 6, minus 2, and minus 3, minus 4. There they all are there, and you can swap them around, but there's symmetry, so that's fine. They're all included. So that was the last line, last term. Middle lines, this many x's and this many x's must give rise to 7 x's. So this many and this many x's must give 7, so all the negatives are gone straight away. And you can see that this one here, so plus 3 plus 4, or as we said, plus 4 plus 3 is fine. So that's the one we're going to choose. And if we make a mistake, we can just try another one. Plus 3 plus 4. Now let's check it. X squared plus 4 plus 3 is 7x's, 3 4s are 12, so that's fine. Next one then, pair of brackets. Here we've got first line, first term is an x, so it's an x and an x. It only takes a moment to draw these lines. X and an x. Last line is minus 6, so we've got minus 6 times 1. There's symmetry, so I don't have to write it down the other way. Minus 3 times 2, minus 2 times 3, and minus 1 times 6. That's all the possibilities. So that's that piece done. Now middle lines, middle terms. So this many x's and this many must add up to minus 1 lot of x, isn't it? So can you see it's this one here? Minus 3 and 2. So minus 3 can go in either bracket and plus 2. And then we can check it's correct. So we've got x squared, plus 2 minus 3 is minus x, plus times a minus is a minus, 3 2s is 6. Okay, next one. 1, 2, 3, 4. 1, 2, 3, 4. First line, first term is just an x squared again, so that's nice, so there's symmetry. Now the last line is minus 18, so minus 18 ones, or minus 1 18s. Now I'm not going to rotate them because there's symmetry. 9 2s, 9 minus 2s, or minus 9 2s, and then 6 3s is the last one, isn't it? Minus 6 3s, or minus 3 6s. There they all are. So that was the last line, last term. Now the middle line's middle term. So this many x's and this many x's adds up to -7. So which one gives -7? See it? So one of these would be -9 and one of them would be +2. So put the -9 here then, say, and put the +2 here. And now we'll check it in a minute. Just tidy this up. Let's see if we're okay. So let's check it. X squared plus 2x minus 9x is -7x. Minus times plus is a minus. And 9 2s are 18. So that's that one done. Now this one, remember what we said about, was it a squared minus b squared? Difference between two squares is a minus b times a plus b. It's a standard formula. So if ever we see anything in this form, we can just write this down straight away. We can write 100 as a number squared, can't we? Write it as 10 squared. And I hope you can see that that's a squared minus b squared in form. So it'd be a minus b, a plus b, a minus b, a plus b. Yeah? This one is, if we write this as, it's 9 lots of b squared, but we can replace that and write that as 3b all squared. That'll be 3b times 3b, which will be 9b squared, which is what we've got. But now we've got it in the correct form, we can just use this property here to see that, oh, it's the difference between two squares. X minus the first term, x plus the first term. And you can check with the expansion of brackets, the 4 lines, that these things are in actual fact the same. Next one. This is just a quadratic. We've got quite a few to do yet. So here, what have we got then? X, oops, 4 lines, 4 terms. The first term is x squared, so the first line, first term is x squared. Then we've got last line, last term is a 4. There's symmetry, so we don't need to swap it around. And then we've got -4, -1, 2 2s, and -2, -2. So those are all the possibilities. The last piece in the jigsaw, we've done the first line, and we've done the last line. This many x's and this many x's for the middle lines must add up to -4. See it? -2 and -2, which you can actually write as a repeated factor. You can write that as x minus 2 squared if you want. X squared minus 2x is -4x, and then minus times minus is a plus, 2 2s are 4. So everything looks okay there. So we've just done that one. Next one. Now there's non-symmetry here because we've got 9x squared, which is a pain. Not a nice example. I'm going to leave that for the moment because it's not very user-friendly. And depending on time, we'll see if I can get them done. This one I'm going to do first because it's a 3, and I know that it's got to be a 3x and an x. So I'll put them there and there. Okay, that's the first line, first term. And then the last line, last term will be a 4. So it's 4 1s. Now because this is non-symmetric, it does matter if you swap them around. And 2 2s, swapping 2 2s around doesn't matter though, does it? Then you've got -4, -1, -1, -4, and then the -2, -2 also. So I'll put it in there. Okay, so that's the second piece, all the products that give 4. Now lines 2 and 3. 3x times this, and x times this, must give rise to -8x. So all the positive ones are gone. 3 of these, and 1 of these. I think it's that one. -2, -2. Let's try it and see if we're right. 3x squared. -6 minus 2 is -8. Minus times minus is a plus. 2 2s are 4. So that's good. So everything's fine there. Okay. Next one. Let's do this one because this is, again, a 2 and a 1 it has to be. It has to be a 2x and an x. but it's non-symmetric. We've got a 5, so we've got 5 1s, 1 5s. It does matter when we swap them, so we include that. Minus 5 minus 1, or minus 1 minus 5. This is plus, so we can get rid of these straight away. Now, the middle line, 2x, second, third, and fourth. Middle line's 2x times this, and the third line, x times this, must give rise to plus 11. 2 of these and 1 of these. So 2x times plus 5, and 1x times plus 1. And that's it there. Good. So we factorise that, and we can check it as well by just doing the reverse, can't we? See if it's okay. Let's try this one then. Now, let's see if we got enough time to do them all. 6x squared. It can either be 6x and x, or 3x and 2x, can't it? But the first line, first term. The signs are taken care of in the last line and the middle line, so we can just put these down to give this product. I don't know what to go for, but I know that's a 7. So either one would be okay. But, do you know, I'm going to try the 3 and the 2. Because I got a feeling, looking at it, from experience, you usually can make an educated guess. If this is the wrong guess, then we just do the 6x and the 1x and see if that works. Which I don't think it would. So anyway, there's the first line, there's the second line, there's the third, and there's the fourth. So we've tried the first line, first term with the 3x and 2x. The last term is minus 3. It's non-symmetric, so we can swap it around. And then we've also got minus 1 and 3, haven't we? And 3 and minus 1. 4 possibilities. Last piece of the jigsaw. 3x times this, and line 3, 2x times this, must give a product of minus 7. So 3 of these and 2 of these. Well, I think it's that one, because that's minus 9 plus 2. So if I put that as minus 3, because there's 3 of those, and 2 of these, so put plus 1 there. There we go. Okay, good. So let's check it. 6x squared. Minus 9 plus 2 is minus 7. Plus times a minus is a minus. 3 1s are 3. Good. Okay. Now, this one, I don't know what to do here. Because it's you could do a 12 and a 1, or a 6 and a 2, or a 4 and a 3. 4 and a 3. 4 and a 3, and this could be a 6 and a 4. Or it could be 12 2s. I'm going to leave you to worry about these, because the time is eluding us. That's a hard example, and I've also left this really hard example for you to have a go at. We've done most of them though, for question 2. But it's just trial and error until you find the right combinations.